Really excited to welcome our first speaker, Erin Bayne, to the stage. So, Dr. Erin Bayne is a professor in the Faculty of Sciences at the University of Alberta. As co-editor of the Alberta Biodiversity Monitoring Institute Scientific Centre, Erin leads efforts to track changes in Alberta's wildlife and habitats, providing critical insights for decision-making. He also directs WildTracks, an open access platform to share and process remote camera and acoustic recorder unit data. He's a valued member of our Horizon Scams Advisory Committee. And today we've asked him to provide a brief introduction to this topic and pose some relevant questions to set us up ahead of before the other speakers join. So, Erin, please take it away.
Well, thank you very much, Stephanie. Today what I'm going to talk about is I'm going to use my example, some of my history, I guess, of where I've worked in big data and data integration, and talk about sort of the example, what we've used, and how I think we can move this to a global scale. So I'm an old guy, and I've been doing field work for over 30 years, and I spent a lot of my time running around northern Canada, measuring trees with a kilometer, VHF telemetry on animals, walking through minus 40 degrees Celsius in the cold to get snow tracks, and getting up at 3 o'clock in the morning. Yes, you have to get up at 3 o'clock in the morning to do bird point counts in Canada. And, that data has been invaluable, and it's a huge archival record that a lot of people have spent a lot of time creating integrated data sets. And I'm going to talk a little bit about that. But one of the things we learned in trying to integrate old data sets like that is it's a lot of work. It's a huge amount of work to go back after the fact and try to put this together. And over the last, I would say, 10 to 15 years, a lot of those technologies have changed. We have LiDAR now, we have, satellite transmitters, we have remote cameras, and today what we're going to talk about, we have ARUs. And these have revolutionized the way we collect data in terms of the velocity, how fast we get it, the volume, how much we get. But there's a lot of issues that we're going to have to rectify if we want to make true use of this data. If we don't get ahead of this soon, it'll just swamp us and overwhelm us in a way that we just will not be able to catch up. So this is just an example of the old times, right? Of trying to bring together everybody's point count data in Canada. And this is, shows the amount of time it took us to actually bring together everyone's point count data, standardize it in a way that was useful. And what you end up finding out is everybody does things a little bit different. And the challenges of a little bit different is analytics become more complicated. It becomes harder to put it all together and analyze it. And it takes a lot of time to figure out how to do that. So what we've been working on is with bioacoustics is when I personally here in Alberta started to recognize that people were going to start to use these as replacements for some of this historical data, I wanted to get a platform in place that helped everybody work together in a centralized way where they could all do what they wanted to do individually, but we'd be actively following a set of database standards and rules that would let us share the data much more effectively and efficiently. So the kind of stuff we're talking about, though, is a very rapidly evolving field. And one of the things that I think is a fundamental challenge going forward in bioacoustics in terms of using it for long-term monitoring, change, habitat modeling, and things like that is we have a huge array of technologies out there. We talked a lot about what's coming in the future and what they're capable of doing. But each of these has their own strengths and weaknesses. And if we don't keep track, for example, of the model, the age of it, the calibration of it, many of the patterns that we're going to see in the future could be driven by changes in technology more than the actual changes in the systems themselves. And so a big part of our system is about tracking not only, the bioacoustic signatures, but all of that metadata that comes with it. What was the model of your ARU? When did you buy it? How long ago did you fix it? What were your standards for fixing it? And so we use a lot of this type of stuff in our WildTrack system to be able to manage actually the equipment that's going to be a big part of this processes. So our solution is what's called, and I call it a Canadian solution. It is not that it would apply anywhere else in the world. It's simply sort of that's the domain over which we have been fairly effective. Is what's called WildTracks, and which was mentioned. So what we have done is we decided to make a centralized system. And by centralized, Most government departments in the country use it, particularly Environment and Climate Change Canada, many conservation organizations, a lot of academics. We've also put in place a lot of things that make industry trust us. So industry will put a lot of their data in that might be private for a year or 2 or 3, and then often gets opened up. And so a big part of WildTracks and its design was making people feel comfortable, making it so that you could do the things on the platform in a way that you felt secure in storing it and managing and making the decisions on who to share it with. And I can talk a lot more about that later, but open access is one component. It's obviously our long-term goal for everything on WildTracks. But in the same light, if you want everyone to participate, you have to give them that comfort level that all that hard work they did isn't going to be stolen overnight type of thing, or is going to be used in a way that's sort of perhaps not in keeping with what their intention was. Now, what the WildTracks platform does, and I don't have time to go through it in great detail because I am going to stick to my 5 minutes, but it really does have 2 main components. It has the autonomous recording unit, digital audio data storage component, as well as a remote camera platform. And I'll talk a little bit more about those in detail in a couple seconds. But what it is, it's an integration between, it's a human AI interface. So humans can do all the tagging if they want. They can identify everything on there, and there's a variety of database standards and tools to make that more efficient. Or, and I'll talk about this a little bit more because I think this is where we're going to be going in the future, we can have AI do a lot of the work for us, and our job is to be the checker of the computer, to be the one that says, you're a little off, or you did a really good job. So we've built WildTracks in about 10 different phases, and there's an old Kevin Costner movie that probably everybody on this phone call is way too old to remember, or way too young to remember. But if you build it, they will come. And when we built this, there literally were 2 groups that used it, my lab and the Alberta Biodiversity Monitoring Institute. We opened it up to a variety of other organizations and said, please come use it. It's free, and it's kind of grown very rapidly. So we have 300 organizations in Canada that use it, with over 3,000 users who are processing data, adding data literally on a daily basis. And this map sort of shows the distribution of autonomous recording units and cameras across Canada and the variety of different people that are actually being able to use it. So centralization can work, especially if you give people that comfort level that the data is theirs to share in the way that they feel comfortable. So this is, I think, going to be a big part of anything that we think about on a global scale. Now, one of the big things, that we can do with this, and this is what's really important, is that the system needs to be flexible enough to not force people into you can only do this. So for example, we've made the autonomous recording side, we allow you to see things in the ultrasonic, we allow you to see things in the subsonic. So if you want to process data for, road noise, you can do that. If you want to process it just for bats, you can do that. If you want to process it for a single species, we have settings in the database that allow people to be flexible. Now, obviously, we can't think of every possible thing people might do with bioacoustic data, but we have sort of like a request form that adds, fields to the database when we think that they can be generalized and added to. So for example, very recently, we added a whole bunch of small mammals to the camera platform because we had enough users who said, hey, I want to actually start identifying all of the mice and things like that. So a lot of benefits and strengths to being able to tell people, are you doing all species, one species, subset of species, that kind of stuff. Most people on the system use it for entire communities, but increasingly people are using it for song rate behavior and things like that. Now, as we're going to talk about, and next week, Justin is going to talk a lot about, the artificial intelligence and automated, automatic recognition. We've built that into the system, but we, having done a lot of research in this area, know that AI has a long way left to go. So one of the big tools, and I think that's something that we probably maybe think about in this group and some conversations, is how does the human interact with the computer in a way to justify, or not justify, but validate what the computer's decided. So we've built a variety of, basically by using the image processing side of our platform, made it so that spectrograms, you can look at all of the individual detections, for example, of all of the Swainson's thrush and quickly go through and confirm that they are correct or not. The other thing this does, it gives you things like amplitude, it gives you the degree to which this spectrogram matches a exemplar recording of that species, and it helps us make sure that the data has what we call high veracity. So in other words, the high quality data where every single detection that someone has done or a computer has done has been confirmed. So today what we're going to see, right, is other visions of what data like this can look like. Our vision really comes from, these ARUs sitting out autonomously in the environment, collecting data on everything, and then giving people the greatest flexibility they need to be able to process that in a way that they want. But ultimately where we're going, and hopefully we can have some time to talk about it, is to be able to let that data be searchable, those raw recordings to be available in a centralized way that people could go, I need a recording from this place at this time to do this thing. And that's exactly what we're doing right now. And hopefully, if we think big enough, we could have a global data archive of a similar level of audio recordings on a planetary scale. So I will stop there.
Thank you so much, Erin. I'm not going to, you've got a few questions coming through on the chat that I'm going to direct you to pick up in the chat. There's one question I'm going to pull about, how do we fund big platforms like that I'm not going to put to you, I'm going to bring into the main discussion. So thank you so much for setting us up.